All right, I'm going to cover the solutions for the Chapter 7, Section 2, Chapter Review Problems. Now, if you look to the right of the screen, you'll be able to see the problems. That way, you can see the directions and everything as I'm going through it. All right, so I'm going to start with number 16, and here's what they want us to do. They just want us to compare the parent graph compared to this graph right here. Now let's write down the equation. Y equals 5 times 2 to the power of x plus 1, and then that plus 3. All right, so here's what this thing looks like. We know it's an exponential function, okay? And I'm going to use a calculator to supplement everything I'm going to show you, but I'm going to do it without using a calculator first, okay? So what I'm going to do is say, all right, so we know what an exponential function should look like. Here's what an exponential function looks like. It does like this, okay? It plateaus off as you go to negative values. It usually has a y-intercept of like 0, 1, but like we talked in the last video, the y-intercept is usually this a value right here. If you take the equation y equals a b to the power of x, whatever this value is in front, in this case the 5, that should be your y-intercept, okay? Now, here's how this looks different from the parent function. The parent function is normally just y equals 1 times, in this case, 2 to the x. All right? Well, the 5 stretches this thing out. It gives it a stronger slope. So it makes it grow a little taller. So if you did y equals just 2 to the x, it might look like this. Y equals 5 to the x would do like this. Instead of it being a y-intercept at 2, it'd be a y-intercept at 10, because you'd multiply the y-intercept by 5. All right? But here's what's important to focus on. These are easy. If you remember from quadratics, and we did it even with like linear equations, the plus 3, what does that do? That moves it 3 up. Now, you see how this thing is really close to the x? So we got the plus 1 is really close to the x. Now that moves it side to side, right? But actually, careful, that moves it 1 left. I'm going to prove to you that that's exactly what those functions do, okay? Let me open up a little browser on Desmos. You could do this in your calculator. I just find Desmos can be a little easier to read. So here's what I'm going to do. I'm going to put y equals 2 to the x. And notice again, it has a y-intercept at, 0, 1, because it'd be right there. So yeah, this one would have a y-intercept at 0, 5, the new one. But so let me show you that. So 2 to the x is the parent function. The function we have is 5 times 2 to the power of, it's not just x, it's x plus 1. I don't have to put the parentheses, I'm just choosing to. Sometimes in your TRD4 it's better to put the parentheses. Now let's compare these values right here. Now, like I said, I was expecting the y value to be wait, what wasn't it? Didn't I say 10 earlier? Well, why is it 13? Oh, the 3 shifts it up by 3. Okay, so here's the thing. Normally the y-intercept is a certain value. But what we're doing is if you take 2 raised to a certain value, and actually, like, it should actually be a 5. But let's do this. Let's compare these things one at a time. Y equals 5 times 2 to the x. Wait a minute, that one does have, the y-intercept is like this right here, where here's what happens. When you move it to the left, watch this function. If I take that plus 1, see how it moved it to the left? Oh, wait, no, I want to put it right here. I want to do, yeah, so apparently you have to use parentheses. The plus 1, that moves it left by 1, so it makes the illusion that it's shifting it up, but really I'm shifting it to the side. So here's the thing, just pick out the pieces. It's shifted 3 up, it's shifted left by 1. If this is a minus, it would be right by 1. And the last one is that it's stretched by 5. So this 5 right here is a vertical stretch. Now, if you remember all those pieces, that means number 17, I'm going to fly through really fast, okay? So you just remembering those pieces, you should be able to quickly answer number number 17, okay? So 17, the equation, you can look on the right if you want to remember it. Y equals 2 times 1/3 to the x minus 2. Now here's what the parent function is. The parent function is just y equals 1/3 to the x. But here's what this thing does. Now notice how it doesn't have a plus at the end. This 2 right here, it's subtracted 2. That means it's 2 actually to the right. You can confirm that in your calculator. And then this 2 right here is a vertical stretch. So it's stretched out, it has like a higher slope. So again, you confirm in your calculator if you want. Oh, but there's one other thing I missed. The negative. Do you remember what the negative does? Okay? Let's show what the negative does. It flips that thing upside down, if you remember. So let's look at it in just this other function. And let's just do this. See how we got y equals 2 to the x? Let me just put a negative in front of this one, and you can see what happens. Boom, flips it upside down. Okay? It's called a reflection. It reflects around the x-axis. So this negative right here, it reflects on the x-axis. Reflects across the x-axis. You could say, just flips it upside down if you want to just like put it in layman's terms to convince yourself. Now, I'm going to work these other ones a little faster. All right, find the amount in continuously compounded account for the given conditions. Now, if you want to review this stuff, when we're doing continuously compounded interest, we use E. All right, we don't just use that 1 plus percentage R stuff. So when we're doing it continuously, here's what it's not. If it was compounded only like once a year, here's what it would be. You'd have 1,000. Okay, and you do 1.048 raised to the x. But I'm not going to do that here because now I'm compounding it continuously. Now your equation is, and you can put a y equals here if you want, but here I'm going to use a for amount. So your amount, a stands for amount, we're using that PERT formula, and again it's because of what the nature of what E is. So your amount is equal to, you take the principal and then you raise e to the power of your interest rate times t. So, and I'll distinguish these two. We want to know if it's compounded after 2 years. I'm going to go ahead and do what I said was the wrong answer, right? After 2 years, this would be a 2, right? So let's just do this. Let's do the amount to be 1,000. Let's do it the other way, the continuous way. E, now the R is just 0.48. When you're using the E, you just put the percentage, 0.048 rather. 0.048. And then times time, which is 2. I'll calculate both of these so you can see what the difference is between continuously compounded and between just regular compounded. It may or may not be that big of a difference. All right, let's compare them. So let's clear this thing right here. Just get all this stuff out of here. Actually, if you want to clear your whole calculator real quick, second memory, and you see where it says clear all entries and option 3. And just kidding, it did not do that at all. So I'm going to oh man, my mouse is not behaving well. All right, there we go. All right, so now it's working. So I'm going to do it the right way. Continuously compounded is 1,000 times, I'm going to multiply by e to the power of 0.048 times 2. This is the answer for continuously compounded interest. Now let me do it the other way right here, which is if you just compounded it once a year. I'm going to do 1,000 times, and I'm going to do that the old method. I'm going to do 1.048, raise that to the power of just 2. Notice how the answers are really close. Here you get 1,100. Here you get really close to 1100. It's just $2 short. But continuously compounded interest is going to be just always slightly more. So your actual amount is going to be $11,000.76. So it's going to be $11,000, $11,100, sorry, $1,100. My bad. So it'll be $1,100, and I'm rounding up 76 cents because it was 0.759. All right, next I'm going to do 18. Okay, so for number 18, we do the same thing. We compound it continuously. So again, I'm not doing this. I'm not doing the amount is the initial amount and then 1 plus r raised to the t. That's if you compound it just once a year. Continuously compounded, it's going to be, you're going to use PERT, P-E to the R-T. So it's going to be, your amount's going to be take 250, and you take E, raise it to the power of 0.062, because that's what 6.2% interest is. And then you do that for 2.5 years. Okay, and again, notice that it would be really close if I did it the other way. I'll do it both ways again. All right, and I'm just gonna grab this so I just don't have to type as much. And I'm gonna just change this 1,000 to 250. Now my interest rate is 6.2, so I'm gonna change that to a 6 and a 2, and this time it's 2.5 years. So that is my correct answer. I would end up with $291.91. Now, that's the correct way. If I did it the way that we're not asking, and it would give you a number close, you would be close to the right track, but it wouldn't be exactly correct. You do 250, and you multiply it by, if you do it the old way, 1.062. That's a 6.2% increase, raised to the power of 2.5. And again, the numbers are pretty close. It's only like, it's less than $2 difference, in this particular example. All right, wrapping this one up, let's evaluate these expressions to 4 decimal places. This is just practice with what E is. I want you to just really get a feel for E. You cannot do this by hand. This you have to do in your calculator. I'm going to show you a way that you might not have thought to do in your calculator for this one. All right, so these, if you take E and you raise it to the -3, let's do second E, okay, and that's, I'll show you on my calculator as well. To get to the E, I hit second, and then that natural log button, which we cover later. And then there you go, there's that one. Number 21, you just take this E and you raise it to the power of -1. Next one, you take E and you raise it to the power of 5. Next one, you take E and you raise it to the power of negative. I'm going to make this pretty. I'm going to alpha y equals. I'm going to put 1/2 and then hit enter. Now, there is no way to do this really by hand. Whenever we're doing these things, we're usually going to use, you're going to use your calculator for stuff like this. But just those values are what they are. Let me show you another way to do this. Instead of putting them individually into my home screen, you can just graph E to the X. All right, and then go to your table, second table, and I have it set to second table set. I have it set to ask for values, so I'm going to choose whatever values I want. These numbers don't matter at all right here. What matters is I set it to ask, and that's how I'll get the same thing. If I go to second table, if I type -3, which is what number 20 is, notice how I get that same answer. If I take -1, if I take 5, and I take -1/2, I get all those same values for what the values at E are. Again, I have E to the X as my Y equals, so that's the answers for 20 through 23. Okay? All right, that's it for the section 2.